we're going to take a look at this factoring graphic organizer, because right now, at the end of this unit, we have gone through essentially 5 different types of expressions that can be factored. So let's sort of sort them out. So we've got our basic, here's our basic general formula of a quadratic equation, where we have ax squared, so some leading coefficient, could be any number, x squared plus bx plus c. So that's our general formula for the quadratic. So let's start out with our first type of factoring that we learned this unit, which is the GCF factoring. So let's take a look at an example of that. So if I had 5x to the third plus 30x, and upon scanning that, I see that there is a GCF of 5x. So then you're thinking to yourself, undistribute, because that's exactly what factoring is undistributing. So 5x times what? What would go in this spot if I were distributing that would give me that 5x cubed? And I know that it's an x squared. And then what would go in this spot if I were distributing? 5x times what would give me a positive 30x? And I know that that's a positive 6. So that's sort of a basic GCF factoring. So what does DOPS stand for? Okay, that's just my abbreviation for difference of perfect squares. All right, that was our second type of factoring that we learned, and that type came in the form of a squared minus b squared. Okay, that was our general form for the difference of perfect squares. So we could have something so simple as x squared minus 9, and I know I'm going to factor that into x plus 3 and x minus 3. Or we could have something a little bit more complicated, but still the difference of perfect squares, and I could give you, say, 16x squared minus 9y squared. It still falls into that category of difference, meaning our subtraction sign right here. And then the term in the beginning is a perfect square, and the term at the end is a perfect square. So how would I factor this? Same exact idea. It's what we're doing is we're taking the square root of the first term, so that's 4x, and we're taking the square root of the second term, which is 3y, and I know in order to multiply to get a negative, one's got to be positive and one's got to be negative. Okay, so those are two examples of difference of perfect squares. Okay, so let's jump down to the lower right. Let's talk about trinomial factoring. So trinomial factoring was the third type of factoring, where it could be as simple as this. Now, why would I say that it's simple? Because right now my leader, okay, my leading coefficient right there is a 1. So when that leader is a 1, life is pretty easy. So we need to still think about sum and product. So we need to come up with two numbers that are going to sum to 7, but essentially they're going to have to multiply to 1 times 6, which is just 6. Okay, so if I think about, because that 1 really doesn't affect anything when I'm multiplying, you can go right into what times what is going to give me x squared, and it's x and x. And now I need to think about products of 6 that are going to sum to 7. So I know that that's going to be a plus 6 and a plus 1. All right, pretty basic, pretty easy. Then we came across trinomials with a leading coefficient. So meaning that a, okay, back up in our general formula, was something other than 1. So what if, just looking for my example here, what if I had a trinomial that looked like this? 6x squared plus 7x minus 3. Well, all of a sudden that 6 in the front makes this a little bit of a game changer. Okay, not too much, but it just makes our life a little bit more difficult to factor this. I still think I got to come up with two numbers that are going to sum to positive 7, but that are going to have a product of negative 18. Two numbers, and I might write over to the side, they've got to multiply to negative 18, but have to sum to 7. So hopefully you're thinking to yourself, positive 9 times negative 2. They multiply to negative 18 and certainly sum to a positive 7. So this is where I'm just rewriting this trinomial. And I'm rewriting this middle term using those two factors that I came up with. So 6x squared still stays the same because I'm just rewriting this middle term into plus 9x and a negative 2x. And then I still have that minus 3 constant on the end. So this is where I take and I group my first two terms and my last two terms. And I do some GCF factoring. So what is the GCF in this first group? It's 3x. And I'm left with 2x plus 3. Don't forget, always keep that sign that's in the middle. So what is my GCF of this second group? And I know that it's just a negative 1. And what am I left with? 2x plus 3. So examine this whole expression. What do they share in common? 2x plus 3. Because essentially that's another GCF. And then what's left over? Reading from left to right, 3x minus 1. So how could you go about and check any of these? Back here to the trinomial. That's all you would have to do is double distribute. And when you went through and you double distributed, you should end up with the initial trinomial that we started with. So just distribute or double distribute is a very quick check for factoring, because what's the opposite of distributing? It's undistributing, which is another word for factoring. So now let's go to factoring completely. So our example that I want to work with, I've got actually two of them because there's two different types. The most popular one looks like this. So if I had 3x cubed plus 6x squared minus 9x. And I always have to examine my expression to see if there's a GCF. And when in fact there is here, my GCF is 3x. And I told you, when you see the word in the problem completely, factor completely, that needs to be, that's your key word to say, I'm going to have to factor at least twice to get to my final answer. Okay, so keep in mind, that's your key word. If it says completely, you're going to have to factor at least twice. So my GCF, and now what's left over? I know that it's x squared plus 6x minus 3. Now this trinomial that's inside the parentheses here, this can be factored. Whoops, I made a mistake. Let me back that up. You guys probably caught it. And that's not a 6. That is a 2. There we go. Now we're working. So this trinomial can be factored again. 3x. Now I just have a basic trinomial because my leader is 1. So what times what gives you x squared? It's x and x, and I still need to think sum and product. So two numbers that are going to multiply to a negative 3, but add to a positive 2. And hopefully you're coming up with plus 3 and minus 1. Okay, again, you certainly could check this. You could distribute this 3x to this x plus 3, get a binomial, and then multiply that binomial by the x minus 1, and you should end up with our initial problem. The second type of factoring completely that you could see looks like this. We had one similar to this on our weekly, on weekly 13. Now, upon examining this, there is no GCF there. But I notice I have an x to the 4th here. Now, that's something out of the ordinary. Okay, that's not a quadratic. So I would still start with what times what's going to give me x to the 4th. And I'm still thinking sum to negative 2 and a product to negative 8. So two numbers that multiply to a negative 8, but sum to negative 2. So I'm going to start off with x squared and x squared, because that, when I multiply, I'm going to add my exponents. That's going to give me x to the 4th. and two numbers that have multiplied to a -8 but combined to a -2 or sum to -2, and that's going to be a -4 and a +2. But again, scan your answer, and hopefully you're picking up on this x squared minus 4. What type is that? That's our upper right. That's our difference of perfect squares. So I need to then factor, again, that x squared minus 4 into, whoops, sorry, my stylus is got a mind of its own. Let's erase that. And it won't even let me erase it. There we go. X plus 2 times x minus 2. And I have to still bring down that x squared plus 2. That would be factored completely. So I'm going to highlight my final answer there because that got kind of messy with my stylus acting all wacky. And there's my final answer for that type. So two different types of factoring completely, but still you had to factor twice. All right, and you need to be able to recognize those. So hopefully this graphic organizer will help you sort of pull all these different types together so that when you look at an expression, you'll know which one you need to use.